Second. So now things will change a little bit when it comes to graphing and when it comes to stating the domain and range. Okay. Oh, sorry. Include all intercepts, vertex, and equation. Now the equations are going to start looking very weird. They're going to have larger numbers and values as in front of them. The coefficients are going to be interesting here. The axes, the independent. The independent variable will always be on the right side of the equation. We call it right-hand side, okay? Right-hand side. So the independent variable is always there. It goes on the x-axis. That's just so you remember, it goes on the x-axis, right? The dependent variable okay? And this is also for grade 12. Because the letters that are being used will no longer be X and Y. Okay, there will be S, T, V, whatever the context, H for height, whatever it is in the context, that's what we're going to use. Okay. make sure you have a consistent scale. You can't just say, oh, I'm running out of room, I'm going to make the next one be 50, right? Whereas you went up by 10 previously. So every axis has to have a consistent scale, okay? And this is very important. Most of the time you will be staying in quadrant 1, where y and x are both positive. Not always, because there will be examples where, for example, something like a diver jumps into the water, right? So you're going from above the ground, the height, right? And then you actually dive down and you go below the surface of the water. So there will be a few instances where that's not the case, but for the most part, that is what it is, okay? So a graph of a word problem, okay, will most likely look like this in general, okay? And quite often, this is just an example, right? The x-axis will now be representing the time, and we will also say that what the units are. In this case, time and seconds, okay? It could be minutes, it could be hours, it depends on the scenario. And this would be the height, let's say. And it could be meters, it could be various units. Oh, I don't even know, Mark. It just happened. All right. So the height and time. So you will see the equation will have h and t most likely as the variables. Okay. So let's graph the path of a projectile. So if you're in physics, right, you will have done this. So somewhere up here, I'm not going to have any units. Let's say you have a ball and you're on top, you're at a balcony and you throw the ball out. So we'll go up a little bit and then it will go back down. Okay. So have this there, have a curve there, because I'm going to show you a few things. This is for us the y-intercept, obviously. No news there. In this case, this is our x-intercept, but I will tell you what they mean within the context. This top point here is what we call the vertex. Okay? And you have to know that these are the most important points to us. They're very important, right? Like the intercepts, in this case, you have 2. You have the vertex, your labeling, and your calculator, though, okay? Pay close attention. Your calculator will graph the whole parabola, right? When you enter this, it will not know that you're talking about a word problem. So I have a lot of students graph the whole thing, okay? And that's beyond the domain and range. Like right now, time cannot be negative, right? So you couldn't even have anything here. And in this case, it will hit the ground, so it doesn't go below the ground, so you couldn't have anything passed down here on the past the x-axis. Okay, so still we refer to them the same thing, but they mean something quite different here. The y-intercept for us is what we call the initial height. Okay, we call it the initial height. That's the height at time 0. So as a coordinate, we would say 0 and then whatever the height is. At time 0, there's a certain height that we're gonna have to calculate using our TI-84. The vertex in this particular scenario would represent the highest point. The highest point. Okay? And still, the vertex has coordinates, right? And it's always going to be, in this case, x represents time and y represents height. Okay? So the coordinates to this point right here, when you calculate that, they mean something. The x value is our time, the y value, right? So we still know that this is x and y, but they mean something for us right now. There's a context around it, okay? So the highest point, there we go. And this would be, the x-intercept would be the time at which you hit the ground, right? So the y value at this point would be 0, and then that's where the object hits the ground. Okay, the object, whatever that is, or the person, right, hitting the ground there. Okay. So this is an example. I find it that students appreciate this, right? It's like, oh, okay, we still have x-intercept, y-intercept. What about this x-intercept over here, Mr. Dirksen? Because my calculator gives me a negative something. Don't worry about it, right? This is a word problem, okay? So you have to kind of switch. How do you know that it's most likely going to be like this? There's a word problem preceding it. If it's just an equation, I'm giving an equation, I say graph this, everything, all 4 quadrants go. If it's a word problem, it looks more like this. Okay, so I will also give you what the domain and range will most likely look like. In this case, and they will have square brackets unless there is a question where there is an infinity, which in grade 11 we don't really do. In grade 12, you will have some infinity situations like money growth, right? Money keeps growing and it can actually keep growing forever. So domain would start at 0 because domain represents my permissible x value. So I start at 0 and I keep going until you hit the ground. So you would essentially put the x-intercept in there. My range, this is the tricky one, okay? Instinctively, you're going to say, well, I go from here to here, right? My y value goes from here to here. But really, if you look at the whole graph, 0 is also included because you're hitting the ground. There's still y values here that you have to consider. So this would be 0 to y value of vertex. Because think about it, the permissible y values would be all the way from the ground, keep going, keep going, keep going, all the way to the highest point, which is the y value. In this case, it would be the height. Okay, so maybe I can put down in this case, it's height, but it won't always be height, right? It depends. All right, so I'll make sure you write this down, okay? So I'll have it all on there. And we'll do some examples here. We're all good? Okay. That's why I love having students in class. I have a cue at least what to go by. It's like, okay, they're done. Let's move on. So first example. So we're going to do a full word problem together, okay? It's 127, okay? So we're going to do pathway of baseball. I'm going to call this one. Okay. The path of a baseball. That is hit has the equation h of t is equal to negative 4.9 t squared plus 35t plus 4, comma, where h of t is the height in feet and and t is the time in seconds. They have to tell you what the units are, okay? Identify the variables. So we like to work with x and y, okay? We like to keep it that way. So we would just say the x is my independent variable, and it is always to the right of the equation. So whatever is on the right side, in this case it's time, so we're going to call that time in seconds. Y, on the other hand, is going to be height in feet. And it's not always going to be height and time, folks, but it is a very common one to use. B, graph on calculator. So let's graph this on our calculator, okay? So you bring that in, clear whatever is there, and you're gonna obviously have to type in x instead of the t's, right? So whatever variable they use, we're gonna always say we're gonna use x, right? So negative 4.9 x squared plus 35x plus 4. And then I hit graph. My window is not appropriate. So what I'm going to do is I'm going to go zoom 6 just to reset. And this is a word problem, correct? So I'm more interested in seeing quadrant 1. Okay, so watch what I'm going to do. Window, X min, I'm just going to go -5 because I don't need to see that much there. X max, I think I was seeing everything there. So I'm just going to leave it like that. Y min, I'm going to go -5. And Y max, I have to increase that significantly. So you can go 30, 40. I'm going to go 40 for now. You choose whatever you want. So -510, -540. I'm going to hit graph. And it's still not quite where I need it. I need to increase my Y max. So go back window. I'm going to go 100. And there it is. Now I see the whole curve. That's all you need. You need to see especially quadrant 1. Make sure you see your x-intercepts, and then we're good to go. Okay, so we did that. I'm walking you through it, right? C, determine the maximum height. Determine the maximum height. How would you do that? Find the vertex. So let's go ahead and find the vertex. We would have to go second, trace. In this case, it's pointing downward, which we expected, right? It's a negative 4.9. So there's going to be a max. That's how we find the vertex here. So we're going to go max. Second trace max. I'm already to the left. Go over it. So it's 3.57. Rounding was another issue that I saw. Okay, so you gotta work on that. 3.57 and 66.5. So I'm gonna write it down. I'm gonna write down the coordinates of the vertex, knowing that this is the time and this is the actual height. Okay. Every single coordinate you find, the first number is the time, the second one is the height at that point. Okay. So what is the maximum height? It is 66.5 feet. Don't just leave it like this. If you give me this, it's not quite done. You're close, but you're not there. So the maximum height is 66.5 feet. That's what it is. So you have to tell me that in a short sentence, okay? D. How long does the ball remain airborne? Basically asking how long is it up in the air. So we're gonna go ahead and figure that out. So how would I know how long it was in the air? Well, think about it. If this is our graph, does it start at off the ground, or is it a little higher off the ground? Does it start right at 0, 0, or does it start a little higher off? What do you think? Let's look at the equation. It starts at 0, 4. Right? So it actually is a little higher off the ground than it does this. Okay? So the time it spent from here all the way to here, that is in fact how long it remained airborne. So we need to find the x-intercept. That's going to tell us how long this thing is. So find the x-intercept. So we're going to go y2 is equal to 0, second, trace 5. And let's go ahead and find that. I don't care about this one. Watch. Okay, find the first one. You just go closer to that one. There's a negative, right? I'm going to zoom in. It's a negative 0.11. Omit. Do not worry about that one. You cannot have negative time. Action starts at time 0. Okay? So we're going to find second trace 5. Do this all over again. And I'm going to go closer to that second one there. Enter, enter, enter. And that is 7.26. Okay, 7.26 is my answer there. So 7.260. I would maybe do this and just say that omit negative x values. Okay. Ball in the air for 7.26 seconds. The question could be worded in various different ways, right? You could have asked, like, when does it hit the ground? You would say, well, after 7.26 seconds, right? Calculate the height of the ball after 1.5 seconds of being hit. So notice that uh, the path of this ball is being modeled by the parabola, which has the equation that's given to you. Okay? So how would you do that? What are they giving you? This is time, which we know is an x value, right? So they're basically saying if x is equal to 1.5, what is y, right? If x is equal to 1.5, then y is equal to this. This should take you back to the very beginning when we worked with our calculators, right? How would you do that? Second, trace 1, x is equal to 1.5. We're going to find the y value there. So we're going to go second trace 1, 1.5, hit enter, and you are at a height of 45.48. There it is, the y value, 45.48. So the height is 45.48 feet. There it is. How long did the ball remain at or, suppose to say or there, above 49 feet? Before I answer this, I just looked at my notes one more time. I'm just going to go to A here. I always like students to still think of every point as time and height in this case, right? All the way to A and just say my x is time, my y is height, like that as a coordinate. Okay, it's just always a need to know, right? Like if you see a point, oh, the first one is time, the second one is height. Okay. Now let's go back to F. Okay, so this one is a little trickier, right? How long did the ball remain at or above 49 feet? So I need a visual here to show it to you. So I'm going to just focus on this. I know that you start somewhere a little higher off the ground at 4, and then it goes like this. Okay? Somewhere in here, there's a height of 49. So let's say this is 49 feet right here. And we're going to call this y is equal to 49. That's going to be our horizontal line, y is equal to 49. And you notice that the ball will be at that height twice. It happens here first, and then it happens here again. Okay, so we're going to find the x value at this point. We're going to find the x value at this point. So there's two instances. It's happening one on its way up, and then it happens again on its way down. And it's the time that elapsed between these 2 points, which is our x values, right? That difference is going to tell us how long the ball stayed at or above 49 feet, okay? So watch what I'm going to do. Grab your calculators, go to y equals, type in 49. In this case, it's 49. It could have been any height that they're asking you for. And here again is that skill you've learned. You hit graph, and there's that y equals 49 line. So let's go ahead and find the coordinates at the first point. Okay, so second trace 5, enter, 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 and that's 1 point. Watch what I'm going to do here, 4 decimals, because I'm not done yet. So 1.6816. And the second point here, I'm going to go second trace 5 again. Enter, enter, enter. That is 5.4613. I'm rounding to 4 decimals, and I will explain that in a bit. If you want full marks in grade 12, that's what you need to do. Some teachers will actually ask you to use all decimals, but if you use 4, you're safe. Okay? Okay, so we've done that. What did we do? We went y2 is equal to 49, and then we went second trace 5. That's all you need to tell me. You don't need to tell me that you did it twice. If you do something like this, I will know. We're going to call this x sub 1, and this is x sub 2, second instance. Okay? Now, we're going to go delta time. Delta time is like how much time has gone by between those 2 points. And we will go time 2 minus time 1. So delta time, the time that elapsed, will be 5.4613 minus 1.6816. So delta time is 3.78 seconds. At or above 49 feet. I don't need long, fancy sentences. I just need you to tell me, answer the question, right? Like this many seconds at or above 49 feet. Just clearly indicate. If you have a different teacher next year, he or she might want to write like full sentences. It's not really required, as long as you indicate the units and you indicate like this is what answers the question. Okay, so this, ladies and gentlemen, this would be a 2-mark question. This would not just be worth 1 mark. So it'd probably be half and half, right? This is probably worth a full mark subtracting because it's a concept. So obviously the final answer would also have to be right for you to get full marks there. Okay. If I divided this distance by 2, you would find the midpoint, like between these two. That'd be the axis of symmetry, right? And that's not what we're wondering. That's not what we're asking. We actually know our axis of symmetry. If I were to ask that, I can't think of any instance where they're going to ask you to find the axis of symmetry here. It's just like I will just ask that outside a word problem. Does that make sense? You're trying to find the whole time that elapsed between these 2 points. If you divided it by 2, you'd find this midpoint here, which would coincide with the vertex, which is 3.57. Good question. Not the same. And I think now we're good to graph. I will first do the sketch and then the domain and range, okay? So continue. Are we good with copying? Yeah. How quickly? The only way, the question was, can you make a calculator speed up the graph? And the answer is no. The only thing that I do know is that when you go to window, and if your scale is very, very small, like 0.01, like if it's a very small scale, the smaller your scale, the longer it takes the graph. That's the only thing that I can tell you. But I haven't found a way to make it faster. That's the downside of these ones, the colorful ones. Like the older ones, they would graph it in a second or less, right? But yeah. All right. We are G, right? Okay. Graph this scenario. And remember, we will label, we will have a scale, and we will also look at the equation. Actually, shape, but for us, they're always the same, but that's grade 12. They would look at, does the shape look like what it's supposed to be? So here we go. Knowing what I know is that there's no indication that this ball is going underground. And obviously time can't be negative. So I am most definitely in quadrant 1. Okay. So I just stick with that. I have already gathered information. I know that my vertex is 3.57, 66.5. So I'm just going to write that down here. My x-intercept, the only one that I care about, was 7.260. My y-intercept, what was my y-intercept again? 0.4, right? It's right from the equation. These points, if you have them, that's all you need to make a decent graph. So look at my x-intercept. I need to have at least 8 units appear along the x-axis, at least, right? Because then you account for that. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I'm just going to label every second one. And before I forget, I'm going to say this is time in seconds. Done. Okay? The vertex is going to tell me what is the highest y value I need to account for. And if I go up to 70, then I'm good. Okay? If I go up to 70, I'm going to account for that. So 2, 4, 6, oh, just enough. 10, 20, 30, 40, 50, 60. This is 70 up here. I'm just going to label every second one. And that tells me that every mark is worth 10. I'm going to make sure I write down height and feet. Before you even start graphing, you should do this. Get all your scaling and get your labels, and you're good to go. And now I'm gonna transfer these points that are so important into here. This is 10, 5 would be about half. So I'm just gonna go a little under and make sure I label that 0, 4. It's not 0, 0, it's 0, 4. Look at your equation. Then I'm at 3.57, 66.5. So this would be 3.57 is right about here. And 66.5 would be right about there. It's not that bad if you practice these, okay? Now, 7.26 is, this is 7. 7.26 is right about here. So now, I'm going to go up, but not straight to the vertex. You kind of want to curve into it and then come back down. ht is equal to negative 4.9 t squared plus 35t plus 4. I have everything I need on this graph right now. Let's do domain and range before the bell. So the shape looks pretty good. There's no V or anything like that. My domain in this case, I like interval notation, okay? Especially for, I go from time 0 to 7.26. And my range, I'm going from 0, because I do hit the ground, all the way to 66.5. If you want it, this is interval notation. If you want set notation, pay close attention. You are going to have to use the variables that are given by the equation. So in this case, it's t. Okay, t, and the range is height, right? So h of t if you want 66.5. But as I said, I prefer interval for that reason. So then you will never have to worry about you losing marks for that. Okay. Your homework consists of page 371. Those are all word problems, okay? I'm going to make sure you know word problem. If you see WP ever, that's word problems. Okay? I want you to graph all of those questions with all the components that go with it, right? Time, height, if it is, right? It could be height and distance. It's not always height and time. Sometimes it's comparing the distance horizontally versus the height. Okay? Make sure you practice how to graph that. The textbook doesn't give you the answers to the graphs. They just ask questions. They don't ask you to graph. I'm asking you to graph. I will scan my answer key because I graph those myself, and I will post them a little later today. Okay, so go ahead and do that. And that's all for today. Thank you very much. I know it's a lot of information, but